Hello, guys.
Hello. Hi, hi everybody.
Hey,
Hello.
So let's start. And last week I was working on the prototyping of a very preliminary placement implementation, but it's a very preliminary because I just started working on the shipping the interfaces and looking at the ZNS API to figure out how it could impact the design of the overall interface interacting with SeaStor. And I will post the a PR for early proof reading. And also I was reviewing Redix and CM's PR and Chenmei's as well. That's me. And Chenmei.
I updated the PR, so I think when the review moves down, I will do the rebase because every merge PR will be affect the files because many files is touched. So after the most comments is updated, I will do the rebase and hope it can be merged after the rebase. And from my side, the manager asked me to if the Crimson OSD can give much better performance. So the next step, I will do the performance testing to give some multiple testing environment test report to show to the manager and Tusha, and to make them think that Crimson OSD is better than Ceph OSD. Then they will think it is necessary to continue on the SeaStor. So before we start on the SeaStor, they want to see the performance testing result.
But I just want to remind you that the SeaStor is I think the SeaStor is more important than the overall OSD refactory or rewrite of OSD, because I think it's more important because it can bypass a lot of overhead where we were being suffering in BlueStor and in FileStor.
So how can we verify it? So they need to see the data, some data.
Yeah. We already have a working Crimson OSD from RBD to disk, but with Alien BlueStar. So is it possible to prove that Alien BlueStar has significant performance issue either in its threading model or its support for inappropriate support for fast flash? Do you have suggestions because we need to convince people that we need to spend a long time to implement SeaStor?
you can point out that if you profile classic OSD, most of the CPU is spent in BlueStor, specifically RocksDB in compaction.
Okay.
It's like that's essentially the argument. That's why we think we can do better with a different backend.
Also, there are tests from Mark Nelson, pretty nice spreadsheet with comparison of classical OSD running MemStor versus classical OSD running BlueStor, and the comparison is made in the domain of cycles per I/O.
Which is another
BlueStor
way of saying that
is
MemStor
3
doesn't really
times
do
more.
Okay,
Yeah,
so it is expected that we can observe the same thing with Alien BlueStar, right?
Yeah.
Not
We'll
do
see
that.
Alien. You should see. No, you definitely would. You would see Alien BlueStor use a lot of CPU.
Mm-hmm.
Right?
How to distinguish CPU usage by BlueStor and the other part of the OSD? How to distinguish it?
Use
You can
perf.
provide it, right?
Yeah,
Perf.
use
Okay,
Linux
use
perf.
perf, right? Okay.
Yeah.
Thank you.
Also, BlueStor
And,
is in a separated thread, so it should be pretty visible even in top.
Yeah.
Exactly. Yeah. And also another interactive evidence is that the rewritten RocksDB using the DNS API, it's reported that it has like 4 times faster than the vanilla RocksDB. So we can foresee
4 times.
Probably we can. Yes.
Well, I've seen 4 times
to...
lower write amplification. I haven't seen 4 times faster. That's different though, but you can actually get that in BlueStor on its own.
So compared to which implementation? Sorry.
The POSIX one.
Well, they're both kind of POSIX, but if Abdulib did some experiments at Western Digital where he re-implemented BlueStor on top of a ZNS drive.
ZNS drive, okay.
Yeah, zone namespace drive, so that there wasn't an FTL, and he observed a decrease in write amplification of a factor of 4.
Yeah.
But that's not really an argument against BlueStor. You can do that with the existing BlueStor. It didn't even require that much change. Now, the argument for why we're doing SeaStor is because BlueStor itself and RocksDB use up a huge amount of the CPU of classic OSD.
Okay.
So it's not unreasonable to guess that we should get the same CPU per IOP improvement on the back end as we got on the front end, if you want to make the argument that way.
Mm-hmm.
That is, we've already demonstrated a significant improvement in CPU per IOP on the front end. If we can get the same kind of improvement on the back end, it would be very worth it, right?
Yeah.
It's also the case that the on-disk structures in BlueStor and the access pattern are optimized not really appropriately for fast NVMe.
Yeah, from design level, right?
Yeah. Pretty much nothing about it is suitable for fast NVMe drives.
Redec.
On the Crimson front, I've created 2 small PRs. One adds the handle error method to errator. Another one is a tiny cleanup in blocking future infrastructure. Also, for SeaStor, the patches, the entire change set, I sent a final revision and it got accepted by Raphael. At the moment, it's only waiting for a match. Right now, I'm working on the watch and unwatch sub operations of the watch op of OSD. I implemented them on the high level. Right now, I need to refactor the lower layer in watch.cc, OSD watch.cc, to work in Crimson world. Doing that right now. Also, I plan to make some vacations, but will be at least partially available. That's me.
Amnon, is there anything you want to share with us? How's your CPT work going on?
Who's this?
Yes.
There we are.
Yes. So I've been having some meetings with Radoslav regarding CVT, just to kind of get more familiar with it. And we already kind of have a plan on to what we want to do right now. So currently we aim to improve improve the compare PY file that I think you worked on previously, Kefu, because if you remember, you told me we want a little bit more detailed matrices. For example, a number of cycles per read, and that is something that we need to be able to get both from the perfstat and the Rados bench, because we get the number of reads from Rados bench and number of cycles from perfstat. And currently, it's kind of unaware. They compare PY files, unaware of monitoring. So we're kind of making a plan on how we can make that work. That well, on runtime it knows both about monitoring and the Rados bench.
Do you get a chance to review the existing bench and metrics? Does it make sense to you?
Yeah, I saw some of the. I mean, I saw the outputs of perf and Rados bench, and it's like pretty simple matches.
Yes.
Matches, and other than that, I didn't really play with it too much.
Okay. Thank you. Ronan.
Hi everybody. I'm late in posting the PR for the async for the ASOC work, and I'm stuck with a question that I wanted to use this opportunity to ask you, if a technical question now, if okay. I want to share a short piece of code. 1 second. I don't know, for me it looks very small. Do you see what I'm sharing?
Okay.
Yeah, I can read it.
Okay, I don't know why I can't, but I'm trying to understand why, if you look at this code, I have a function here, test rate A, which is using async and is using the fact that I can wait in an async in a thread, in a SeaStor thread, and then I was hoping to, if you look at test rate below, I was expecting FR to be ready, available after the async returns.
No, that's not how that works. If this is working the way I think it is, that get suspends the entire call chain and lets it return up to the reactor. So when that shows up, what you actually have is a future that is not ready yet, even though you're actually inside of that call. It probably doesn't make a lot of sense, but it's true.
What I understood is that async only returns when it's ready.
Yes,
Well,
but it's inside. You are thinking about the thing that is inside the async lambda, the lambda that you pass to as async. But you are the caller of your test wait A is actually dealing with a plain future. So I would expect it in this example it never be available.
Yeah,
You would need
sleeping.
to use then.
Mechanically,
Okay.
the way it's happening, that async call passes that future back up to the reactor or something, but immediately returns a future. It doesn't necessarily even run that lambda then. Eventually, when that lambda does get run and that get gets called, what's going to happen is it's going to stack swap back up to the reactor, and it's going to put that task to sleep until the sleep should logically have woken back up. Then it'll untask switch back in, or stack switch back in, appear to return from that call, and then continue on with its life. But the test wait here doesn't care about any of that. It's just getting a regular future.
Okay, so how do I modify test rate A? Is there a way to modify to only return when this 17 is ready?
Yeah, you could wrap the next call out in async, that the whole thing is async. But you're fundamentally, you can't have it both ways. Either async actually waits a second for the sleep to finish, or it doesn't, right? And we don't
Yeah.
want it to actually wait a second. That would be really bad.
What I want is for test wait to have to wait a second here. This is actually what I want, to wait a second and then get the result.
Do you want to actually block the whole reactor thread for a second, or do you just want it to wait before making progress?
To wait before making progress, but I don't want to. I'm trying to find a way to do it without using a continuation here. To have a function that
you can move the async call one layer up and do it that way. That would work, right?
Okay.
Like if you move that async wrapper out to the outside part of test wait, then it would look like you had straight line code, but it actually wouldn't be. It would be stack swapping back to the reactor every time it would block.
Okay, so there is no way to hide a wait inside the downstream function, which is what I'm trying to do. I know I can do it on the upper level, but I'm trying to limit it to
Why do you want to write code that works that way? That's, I guess, my real question.
If you want to link another logic to that may wait for some time, you need to use then, right? You can't use anything else.
Yeah. The way you chain any asynchronous operation.
Yeah, I'm trying to find a way to shorten the if-then sequences, and to hide the waiting in an internal function, more or less. That's.
Yeah, you can't do that without moving the async wrapper to the outermost part.
Okay. Okay.
And you don't want to do that for performance reasons in normal circumstances because it's slower.
Yeah. Okay. This is more or less what I was trying to do in refactoring the code.
Which code were you trying to refactor?
My code. What I was doing. I have a working admin socket system with now for a few weeks now, and I wrote testing some unit test scripts, and under heavy load I still see failures from time to time, and I'm trying to root out those failures. This is
okay. So if you're writing test code and you actually want to introduce a time variance, you can use any normal POSIX call. Like if you do actual real life sleep, it will actually suspend the thread for reals. The reactor won't do anything else during that time. It'll just sit there, but that will work.
Okay, yeah. That's true.
But the reactor will complain if you start for like more than 200 milliseconds. But complain that it does not crash.
You can probably get it to not complain since it is test code. But the thing is, if you're looking for concurrency bugs with different futures firing at different times, this won't do that because it's going to suspend the whole reactor thread. The scheduler won't run, nothing else will run, it'll just sit there.
Okay, so I will try to find the other ways to do it.
So one suggestion is that you could introduce a thing where, let's say, one of the operations you want to model has you want to make it so that one of your async operations has a more variable time cost than it really does, right? That's the whole idea. So you could introduce a debug variable to the library implementing your admin socket that actually just chains a sleep continuation onto the end of each one of them with a random wait. So the next layer up wouldn't see any of that. They would just see a future that has the same value that they expect to see. But in reality, it would suspend or it would, delay the continuation for whatever random time period, or create wrappers for.
That's actually
That's
actually what I did in the real code, in the tested code.
Yeah.
Yes.
Okay.
Okay. Thank you.
Thanks, Jordan. And Sam?
Yep. Okay, so it took forever, but I finally figured out why my thing had introduced performance regression, and it was because I forgot that, or I failed to notice that the SeaStor loggers will actually evaluate their arguments, even if they're not going to run. So I was omitting the PG state string. Whatever. Okay, so that's working now. So it's probably ready for review and probably to merge. I don't think I'm going to rerun the test suite because the part in classic OSD didn't change. So whenever you guys have time to look at it, that's fine.
I'm reading it.
Yeah, I'm moving back to recovery backfill. One thing we should start thinking about over the next 2 weeks is we should come up with a couple of talks we want to give at CephaloCon, because the call for papers deadline is like second week of December maybe. So I'll make a document and share it around if anyone wants to claim a topic.
Yes, we should.
Probably we should. There ought to be enough to talk about to get 2 different Crimson talks. I would think.
Yeah, probably 2 of them. One about the SeaStor and another about the general progress of the Crimson, I guess. Anything?
Yeah, I last week I looked at the Arita PR, but doesn't give any review. Sorry, but seems that to me that Messenger doesn't need to change urgently with this, because the recovery from the failed connection doesn't happen normally, like OSD case.
Oh, actually, this is a good time to chime in. Another thing I did in the last couple of days was I was debugging a bug with the Messenger 2 implementation in Crimson. Generally speaking, dropped connections are not handled correctly. So continuations, yeah. So futures can outlive the messenger, which tends to cause seg faults. I found some of the more obvious ways that can happen, but the other thing that can happen is that when a connection dies, there can be outstanding futures waiting for active gate, or waiting for ready gate. I forgot. It was something in the connection protocol that will fail with a broken promise exception because the promise went away, right?
Could you help me understand how to reproduce those bugs?
Actually, all you have to do is run the current version with debugging on. That's enough. It'll seg fault.
So sometimes it will raise. Okay, I will look at it.
But I wanted to point out that if we did gradually mutate the messenger code to use the aerator, this would have been caught statically, because broken promise would have been one of the things serviced from waiting. You'd have to handle it.
Okay.
Just a thing worth thinking about. I'll link you my PR that has the couple of changes, or the commit. It doesn't actually fix the bugs, but it does work around it enough to use debugging for now.
Okay. So what do you mean by handle the broken promise? Because I didn't see any example. Because from aerator, it defines some errors we expected, right?
Right. So the interface, you would have designed a wrapper around the gate that says among the things that this feature can throw is broken promise. Right? Because that's fundamentally always true with that interface.
Yeah. Broken promise can be raised from that interface, right?
Because if the gate is destructed before it fires, then any future currently waiting on it will get a broken promise exception. Because the gate's no longer there and it's never going to be fulfilled, right? It's true in general. If you set up a promise and a future, and so that the future is delayed until the promise shows up, and then you let the promise be destroyed, the future will fire, but it will fire with an exception, broken promise. So a lot of things built
in general, wherever we use gate, we need to return an error, which implies that something something bad would happen. For example, the broken promise.
Or you have to prove that the gate will always outlive anything waiting on it. That's okay too. But one way or another, you have to make it work.
Okay, I didn't notice it, so I need to take a closer look at it.
Well, and that's why I like the aerator concept. It makes it so that when you're designing interfaces, it points out things that people using it have to know about.
Yeah. So how about because Messenger calls a low-level IO stream, right? But the lower level interface doesn't use aerator, so.
No, it doesn't. We'd have to make a wrapper for it, but that's okay.
So
I just linked it.
Okay.
I'm not saying
okay.
you necessarily have to do this. It's just I was just pointing out that's the type of thing that this is meant to solve. We definitely shouldn't go back and rewrite things for no reason, just to add aerator.
Okay.
But as we change things, it makes sense to look for opportunities. That's all.
So I will look at the bug first. So the second thing I noticed is from the slides, these slides, the BlueStor slides, that there was a design for the logical OSD to allow multiple OSD to run in the same process. It's because some user space drivers characteristics of user space drivers that it is not very convenient if we put OSDs in separate processes. Like for example, the DBDK, it said that this documentation said that there might be some limitations if we use multiple process mode, and even we might use we might need to use the RPC. That is very lower level implementations that is needed to transfer some message from one process to another. So I think if we continue to go on with the multiple process design, we might need to have some more complex implementations on that. So my question is, is it better to go on our design with logical SDs or multiple processes if we really want to use the user space drivers like DBDK, SBDK, or PMAM? Maybe.
So it's worth pointing out that the only reason why it's annoying to run multiple like classic OSDs in the same process is because there are a bunch of process global like variables for no particularly good reason. It was just convenient at the time. We, as far as I know, haven't made any of those choices in Crimson yet. So we haven't really done anything that prevents you from creating more than one OSD in the same process.
Okay.
We haven't implemented it yet, but we haven't really made it hard. I'll also point out that I think the DBDK concern is that if you're trying to run more than one OSD on the same device, then multiple. Wait, DBDK. Oh yeah, right. If you're running multiple OSDs on the same NIC, it's a problem if they're in different processes. So in that sense, it might be helpful actually to run multiple OSDs in the same process.
Another issue is that for example, SBDK, from the slides shared by Sage, it is said that if we run multiple SBDK instance in several processes, it will have multiple DBDK polling threads like that.
Yeah, so this is all stuff we haven't looked into enough yet. So actually, if you wanted to write up like a summary of what we think the important things not to do are, that would probably be good. My understanding, though, is that at least at this point, we haven't done anything that makes it hard to run multiple OSDs in the same process. So we just want to not do that.
Okay. I just want to point it out.
Yeah, it's a valid point.
So I also looked at the SeaStor design. So I have several questions. Maybe I will add it later to that document. And That's all for me. So I already planned. There's a self-allocant topic. I maybe have one about the messenger progress and our native stack evaluation about it in a separate topic. Okay, that's all.
One quick note in the matter of user space drivers, at least for DPTK, it might be worth checking. It might be worth trying the VMDQ or SRIOV techniques to get multiple NICs on one, to get multiple processes on a single physical NIC instance.
But they will have separate IP addresses.
Yes,
they can't share
IP addresses and ports, I think. But it will be it's fine as if we introduce extension to the Radius protocol to avoid bridge, to avoid the crossbar at the level of messenger.
And SRIOV has some limitations. They can only spawn limited number of virtual VF, right?
Yeah. How much?
I don't remember. Maybe 16 or I don't remember.
I see. Okay, not so small.
Okay.
I wouldn't expect that we place 16 crimsons on top on single NIC.
Mm-hmm.
I just linked a doc for if anyone wants to write down self-allocant talk ideas.
Regarding to the one-to-one mapping and M2M mapping, I think we haven't made the choice to use M.
I think there are a lot of reasons to think we're going to end up having to have multiple threads.
Yeah.
I just doesn't seem likely that that's not going to happen. There are too many things have to go right for it to make sense to partition a device among processes.
I think the only decision we made is to not make the decision at this moment because we have a lot to worry about as a short.
Well, actually, it depends on the moment depends on the point of integrating user space drivers. But still, I fully agree that we shouldn't close any doors for both multi-process and single process approaches.
Yeah. Any questions? Okay.
One quick question related to Watch that is already implemented. The implementation in the current implementation in classical OSD. I was thinking about a case when a single MOSD app instance carries multiple Watch sub operations. Like is it even do we have any case, any real user of the Radius protocol that would put multiple operations related to Watch Notify in a single MOSD op?
You could easily notify more than once. I don't think anything does, but that would actually make sense, sort of.
Yeah.
Watching and unwatching doesn't seem like it makes a lot of sense, though. But is there something that it makes easier?
No, I'm asking because I'm worried that in classical OSD that we are doing the op effects of watch and unwatch out of order in different order that we got those messages in those operations inside MOSD op. In such sequence. Actually, I am afraid that we could have a leakage of watch instance because we are at the moment primary log.pg do OSD do op effects actually disconnects first then goes to the list of items to connect. That's a bit
You're
surprising.
probably right. It's probably buggy if you have more than one.
Yeah.
If you happen
Anyway,
to notice what the actual bug is, go ahead and file the bug though.
Okay. Anyway, for the Crimson, I'm assuming that op effects should be perfectly ordered should be ordered in the same manner like operations inside MOSD op.
I think that you should do it correctly in Crimson if it's not correct in Classic.
Yeah.
Yeah, if it's buggy in Classic, we don't want to replicate the bug.
Yeah, that's also my opinion. That's also my thinking.
Yeah, we never want to. We don't even want to replicate implementations that are awkward. Like if we can make improvements on the way it's laid out, we should do that. Just to make it easier on ourselves. Watch Notify is on its third version of the protocol because the first two were really buggy. We missed some things. So some of the ways it works right now are historical artifacts and not actually good ideas.
Okay, I see.
There's a lot of that in classic OSD. But yeah, in a specific case, I think you're right. I think the fact that it maintains separate lists of connects and disconnects is fragile if you have a watch-in or not watch in the same transaction.
Yeah, but it seems that nobody uses that feature, and
no one does. It wouldn't make a great deal of sense. But nevertheless, we shouldn't preserve the bug.
Of course, that's true.
Unless we get a big performance win for doing so.
So another question: have we settled down the interface of our KV store for SeaStor? Is it identical to BlueStar KV?
No. So for almost for sure, we're gonna have. Okay, so just a BlueStor uses RocksDB for everything because it's there, not because it's necessarily a good idea. And ONode data and OMAP data have almost nothing to do with each other. ONode data is known to be, because it's keyed by the object hash, it's known to be fixed size and uniformly distributed over the space because it's a hash, right? By contrast, OMAP data is fully user controlled and needs to be listed in lexicographic order. So it's very likely that those two things will not be the same key value store in the first place. It's also probable that OMAP. Go ahead.
I've got a question. Because the OMAP, each OMAP, a set of OMAP key values need to attach to a object. If that object does not exist, if we want to read the OMAP key attached to it, the OP would fail.
Wait, I'm sorry?
The question is, OMAP set of key value set of OMAP need to attach to a certain object.
Yeah.
If that object does not exist, the read or the range query of that OMAP would fail. So
you get an enoent.
We need to read the object first, but they're not necessarily connected. But underneath of it, but
moreover, objects function as namespaces. You can have duplicate keys on different objects, right? The same key can exist on many objects. There's no reason why not. BlueStor handles this by prefixing them with the object name. OMAP is logically contained within an object.
Oh yes, we can do this.
It also follows, therefore, that
object name.
OMAP. Well, we could do that, or we could make it so that every object has its own little tree, right? It does not need to be the case that all OMAP data spans the entire store. There are, in fact, a lot of good reasons not to do that. Again, the only reason BlueStor does it is because it doesn't make sense to have a RocksDB per object. But depending on how we design that part of the layout, it probably does make sense to just have a few B-tree nodes per object. Way cheaper, potentially.
Yeah, I see.
Depending on many things, but possibly.
Another way is to hash the object part into a shorter key in a B plus tree. I think that would
or something.
Okay.
The design space is really unconstrained. We have no reason to use the same interface that BlueStor uses, if that answers your question.
Okay. I think that does, but does it mean the interface of our KV store, our new KV store has a more constrained interface, or?
Well, it's fully unconstrained at this point. We haven't even decided what it does yet.
Okay.
I think probably we can have a facade which resembles the existing object store, and underneath of it we can have two KV store which serve the object and the and object separately.
There's no reason they would share an interface. They aren't even keyed by the same thing. One's keyed by a string, the other's keyed by an H object. One of the points of this is to avoid constantly stringifying and unstringifying things, which BlueStor does all the time, because it has to constantly turn in-memory structures into strings so it can give them to RocksDB and then interpret them back out. All that stuff costs cycles. We don't want to do that if we don't have to.
Thank you, Sam.
Yep.
So, any other questions? Okay. Have a good day and have a good night. Thank you, guys. See you next week.
Thank you. See you.
Thank you.
Right.
Bye-bye.